Let me introduce you to Luke Sneringer, who will be speaking about making more responsive web applications with SocketIO and gevent. Please give him a warm welcome.
Good afternoon, everyone. I'm going to be, well, actually, never mind. I don't need to say what I'm going to be talking about because Carlos just did. Thank you all for coming. Wow, there are a lot of people here. So this is going to go in 3 parts, and I'm going to talk very fast. The first part is kind of where we are now, what I am jokingly calling the state of the web address. This is a discussion of the problem that we're solving. Traditional HTTP is been around for a while. It's the mechanic by which browsers send requests, get responses from servers. It's stateless, and it's client-driven. Clients ask for things, and then receive a response from our server. They generally don't have, the servers don't retain a whole lot of information from request to request. It's mostly independent. It's not completely independent. We do have some aspects so that you can know that a user is the same user, that kind of stuff. We use cookies, we use sessions, which are built on top of cookies, various different things like that. But functionally, the design of this thing is that each request is independent from request to request. And that actually is a very big problem for the web, because as connections have gotten better, we are interested in having more and more stateful connections. So nowadays you look at the web and you contrast it with something like, say, online multiplayer gaming. If you're doing this or this, then you're doing things where you're opening a stateful connection with a server and keeping it, and the server is sending data back and forth to you all the time. That's very difficult to do on the web. HTTP, as I said, is at a fundamental level very client-driven. The client asks for something. The client is the instigator of the process. The server complies with the request, returns a response, or sometimes doesn't. And the thing that I'm trying to stress here is, again, that the client is always the instigator. We have lots of things that are built around masking this notion, a big one being AJAX. It's still built around this fundamental order. You're still asking for material from a server. The client instigates a request. It doesn't necessarily do it because a user hit refresh or any number of other things, but it still is the client asking for a server, the server responding, sending a response, and then the client inserting it in a page. Generally, you're asking for things on a cadence is very common. If you're trying to do, say, an AJAX chat room, you're constantly asking whether or not there is new data available in this chat room, which is fundamentally, are we there yet? Are we there yet? Asking like a 3-year-old. Like that. We have been working around these restrictions for a decade or more, in addition to any number of other restrictions. Almost every single thing that you can think of that has become popular on the web, Flash, AJAX, Comet, long polling, these are all notions that are attempts to disguise, adapt, do something to this paradigm to make it so that servers can send information to clients, so that you can send an information to a user without the user asking for it. And SocketIO, which is what we're going to talk about, isn't actually different. It's just the new hot way to do this cover-up. SocketIO is a JavaScript client and server library. The server is, there's also a SocketIO server implemented in Python. That's what we're going to talk about. It's a new solution to the last mile problem, how to get information to a browser without the browser repeatedly asking for it. And really, it's just the new browser-compatible way to maintain a stateful connection. I said a second ago that it's a JavaScript library. The server is also written in JavaScript. It's written in Node. Node.js is a very popular JavaScript framework for both clients and servers. There's also a Python SocketIO client, which is what we're going to be talking about. This is going to be our focus. And that's where we're going next. First of all, if you want to do anything with SocketIO, you'll need to include the SocketIO client on your browser. This requires you to get the client, which of course means that you should just download it from http://socket.io, correct? No, not even remotely. It won't work at all. There is no download link on SocketIO to download the SocketIO JavaScript client. And it makes you a sad panda, as does the fact that I didn't do the resolution here very well. You can't do it. They don't make it available because their entire notion is around doing this in Node, and they have this really clever Node way to serve this data. So when you do go to get it, you're going to want to go to the gevent SocketIO repository in GitHub and then go download it from one of their examples. Very, very clever. I'm also making a tutorial repository available. The link that is half gone in the bottom left, I'll be giving it in the last slide. I apologize for that. We'll also have it. And so you can get it from there. The SocketIO client is actually very, very, very simple. It does very, very basic things. It opens and holds connections to a server, sends data to a server, and listens for data back. Not particularly complicated. Open a connection, listen for data, send data. And in SocketIO, they have nice terms for these, which are called connect, emit, and on. Here's how to connect to a server. The SocketIO JavaScript library will make the I/O into a global variable. That's var at the top. Again, sorry about that. And then you just connect to your server / your namespace. If your browser supports it, it uses a technology underneath called WebSocket to open and hold a connection. If it doesn't, then it does this degrading situation where it tries the next best thing that your browser can do. It'll try Flash. If your browser has Flash installed, it'll try long polling connection, and it'll actually just try Ajax polling if it has to. So it will try to mimic the desired behavior without your having to worry about it. That also means that SocketIO works out of the box on every remotely reasonable browser. Namespaces are a SocketIO term. Notice I put / namespace here. It's basically SocketIO's internal URI routing. Sort of. Except not, because these actually don't map to URIs at all. It's a dirty lie. It is a complete dirty lie. You cannot go to http://server / namespace in a browser or anything other than a SocketIO connection and get anything at all. And you'll be very confused if you try to serve things out of that. And we'll get back to that when we get to the server side. The emit and on methods, the other two, are about sending and receiving events. On is what you do to say that you're listening to an event. It's basically a subscription method because JavaScript is all about event-driven programming. And emit is about the server sending information down, or the client sending information to the server. It's called emit on both sides. Emit sends, on listens for receipt. On the server side, emit sends to the client, on listens for receipt. Events are not particularly complicated things. They comprise one, a string, which is the name of the event. They can be anything you want. I assume they probably need to be ASCII, but that's about it. And some number of pieces of data, probably more than 0, but it can technically be 0. And you have anything that can serialize easily to JSON open to you because it needs to be JSON on the client side. So strings, lists, dicts, booleans, numbers, and any combination thereof. Asking for an event, receiving an event, basically involves setting up a listener. When you say socket.on event name, all you're really saying is, I want to know when I receive this event. I want to know when X happens. If a server sends down an event saying foo, then I want to run my method that's going to be attached to the foo event. If it sends down bar, then that registrant is not interested and doesn't want to be bothered. The server can send more requests than the client actually asks for. In fact, it very often will. And I'm sure that my code is going to be slightly borked on the screen. Again, apologies, but basically it looks like something like this. Again, this IO connect we've seen earlier, this is running the connection. And then when it receives the event saying that the connection has succeeded, it's just going to send some data back to the server. That's socket on the left there. So when it receives an event called connect, it will run this function. and it will emit something back. It will emit an event called hello, which then the server will receive, or maybe ignore, and my name, or someone's name. On waits for the event to come in. When the event does come in, the function runs. If an event comes in and there's no registrants, no functions registered to run on the on event, then nothing happens. If something comes and it has 2 registrants, they both run. Order is not guaranteed. As a quick note, the server actually will emit connect automatically with no data when you successfully connect. You'll automatically get that connect event, which is great for testing. And lots of production reasons, too. Emit sends data back. So like I said a second ago, I've created a hello event, and I've sent back my name as an argument. The argument is fundamentally positional. You can have as many as you want. I did 1 because otherwise the code would be even more too long for the slide. And we'll come to that more on the server side, which leads us to the server. A quick note about what's available. SocketIO is designed by the SocketIO people to be a JavaScript client and server library. It's built around being a node thing. A node thing is a server platform. And if you use SocketIO, they actually assume that everyone is doing this on Node. But it wouldn't really be appropriate for me to be talking about SocketIO at PyCon if I was talking about the Node.js server. And I actually think that a Python solution is a better option. There's a Python library called gevent. There's been several other talks that have mentioned this in different ways. And gevent SocketIO, you can get them off of the Chi shop, off of the Python package index. And they offer you a couple of advantages over JavaScript. In particular, your debugging will be much cleaner. And your code is more straightforward. JavaScript has this notion of everything being event-based. In the Python library, looks much more like a traditional class. And it's just much easier to work your way around. And your errors are nice tracebacks. Like I said, we're using the gevent-socketio library. It's available on PyPI. I'm going to show you an example. Again, I've made it available on GitHub. We'll get to that at the end. And for this example, we're going to integrate with Django. There is nothing Django specific about doing this. You can use Flask, you can use Pyramid, you can use Web2Py, you can use nothing at all. But in order to make this easy, in order to focus our time on actual SocketIO things, we're going to gloss over the Django stuff and just talk about SocketIO. So the basic steps are install the SocketIO server, run the SocketIO server, and route requests. SocketIO server is generally set up to take requests at a specific endpoint at your server, usually /socketio. So not every request that you send is a SocketIO request. There is a notion where you're going to have your normal requests and your SocketIO stuff. So say you have a really, really simple chat room library. You might have a normal Django stack that lets you create rooms, delete rooms, decide who is the op of those rooms, various other things like that. Those are traditional requests. And then you have the SocketIO piece, which is actually connecting to the room, immediately being notified when someone talks in it, all that kind of stuff. You have one endpoint that is your SocketIO endpoint. By default, it's SocketIO, /socket.io/. I will get to this a little bit later, but you usually don't want to change that default. You have to change it in like 8 different places. It's painful. And this is the actual URL that is expecting a SocketIO request. Remember how the SocketIO client did IO connect server /namespace? It's actually going to connect to server /socketio/ some other stuff depending on your particular fallback, like /1/WebSocket or something to that effect. And then there could be a /2/flash or whatnot. That's the actual endpoint. The namespace is fake. It's a lie. Running SocketIO is pretty straightforward. Every environment is different, whether you're using Django, whether you're using Flask, what you're doing. So you're probably going to do some scripting, but it's going to look basically like this. You're going to import gevent. With gevent, most things you end up wanting to put this monkey patch all at the top, or things just don't work. You're going to import your SocketIO server, and then you're going to start your SocketIO server. You're going to hit your host and your port. Your port can sometimes shares nicely with your dev server or may not. You have your WSGI application thing. If you've used Django or most other web applications, you have your WSGI.py file or something that creates a WSGI application object. It's just asking for that. It talks to the same WSGI application objects that all of your frameworks do. The resource, that's the URL. Again, I really don't recommend changing that because you have to change it in multiple places. That is the default, so you can leave it off. I've left it for explanation purposes. Policy server, that's whether or not to run the Flash piece. That obviously will require more resources. If you don't need the Flash situation, you can change it or turn it off. Then you just hit SocketIO server serve forever with something to be done if you say raise keyboard interrupt and need to get out. We've already talked about WSGI application. It's the handler. Resource is the actual REST URI. Policy server is the Flash server. And the server can handle normal requests. The SocketIO server that's provided there will actually take regular web requests to other URLs and route them through Django or Flask or Pyramid or whatever you're using and send the right thing down. That comes to the URI routing issue that I keep saying the cake is a lie. Assuming that you're using the Django bundled WSGI application, we'll now go through the normal Django URL routing. Most of you, hopefully all of you, have seen this before. Django conf URLs, import pattern, import URLs. You have your pattern. There's your home view. There's something regular. And then SocketIO has to go to our special SocketIO view. I've gone through this already. I don't think I need to go through it again. The boilerplate Django view, I'm going to show you a view in a moment that's going to send us into the SocketIO ecosystem. And then the SocketIO system has its own URI routing. It's not a true URI, but it's a URI-like thing, so that's what I'm going to call it. Their equivalent to Django views are called namespaces. You saw namespace in the URL earlier. That is the thing that routes it to a class that understands certain kind of messages and has certain kind of listeners registered. Each namespace is a class. Like I said, it maps to something that looks like a URI but really isn't. And a very simple class might look, this is our Django SocketIO view. This is pretty boilerplate. Your actual view doesn't need to look very much different than this. So first we're going to check and make sure it's a SocketIO request. If you point a browser at it, then I'm just going to send down a 400 with a very small amount of text and tell you to go away and bother me later. SocketIO manage is imported at the top. It's going to take request.environ, which it needs certain various things from. It's going to register certain namespaces. These are the things that we're going to write. I'm going to show you these in a moment. As a third argument, it can take a request object. It can take a request object from any of the Python frameworks. You can send nothing if you don't actually need that. But fundamentally, it's if you need to send your framework data so that you can say, look at what user this actually is in your Django ecosystem, that's how you can do it. It's available within your namespace as self.request. And then I have some error handling so that things go where I want them to go. And then at the bottom, I just return an empty HTTP response because Django requires its views to do so. I've already gone over that when looking at the code, but it will be useful for people looking at the slides later. Namespaces are actually really, really, really basic things. They have an initialize method. They need dunder in it for their own purposes, so you can define a method named initialize that has your setup stuff. And then they just have on event name. Or event name is whatever event you're receiving. So just like you were doing socket.on your JavaScript side, you're going to have on underscore some basic string on your Python side. So when I did socket.emit hello Luke Sneeringer, this is where I'm going to receive it. I'm going to import base namespace. Again, they're using dunder in it and several other things. Subclass base namespace as my namespace, which I put on the /namespace fake URI earlier. On hello, hello there maps to hello there. And I'm expecting one argument. That one argument is going to be my name as a string. And I'm going to send back an event I've made up called hello underscore ack and it's going to tell me hello to make me feel very welcome. Data passed back and forth doesn't have to be strings. Anything that will run through json.dumps will work, which basically means that you have available to you strings, ints, floats, bools, lists, and dicts. You can't send down Python classes, at least not in most cases unless you're doing some fancy things. You can send one argument or you can send more than one. So if you would like to send a dict that has all the stuff that you need, you can do that. If you want to send a set of arguments in positional order, you can do that. They will maintain their positional order. JavaScript does not support keyword arguments, so you can't do that. One last thing is the last mile. Once a SocketIO connection is in place, your namespace can emit an event which the client will now immediately pick up. Whenever you send self.emit with some amount of event and some amount of data, it will hit your client essentially immediately, provided there's no network interference or anything along that line. But the on method is really only giving us functionality we already have, albeit faster. Client makes a connection, it sends something down. There isn't any real way to get into this class, into this namespace class, and send stuff in. There are any number of solutions to this problem, and once you have this framework, it's very easy to do it. So the more interesting problem is, how do we send data without being asked? If you have a celery task that's adding something that you want to now send down to everyone who's connected to a room, you want to know how to do that. It's really easy to just send something in from a browser and echo something back, but that's not giving us anything we didn't have before. Now that you're holding a connection, there are lots of ways to solve this problem. I'm going to propose one. It is not the one and only solution. There are many others, but it's an easy one that I can show in not very much code, which is to use Redis. Redis is useful for lots of things, and this is one, because Redis implements a pub/sub implementation. It implements pub/sub, and it's really, really, really easy to add it to a namespace. And let's see what that looks like. Notice we still don't have a lot of code here, although we're not doing anything either. So now I have my initialize method. I'm saving a Redis object to my namespace class. This is user specific. Every separate connection will have a different Redis object, which means they have their own pub/sub object. I can use Redis, self.redis.subscribe at any point to subscribe to any Redis channel. And I'm spawning a greenlet that is going to listen to all of the Redis channels to which I am subscribed. If it gets garbage like a new line for a keep alive, it will ignore it. If it gets something with a data key, it will know that that's interesting. The data key has to do with how the Redis pub/sub implementation is done. It will always have that. And then I have decided that all of my data will be sent in a way where there will always be an event key, so I can assume that that's there. That's just a rule that I've made up and would have to follow internally in my implementation, and whatever data, which would send down as a dictionary. You can subscribe to Redis's broadcast in your namespace on methods. So you could have something that says, I'm joining the foo chat room. So the onJoin method would then say, OK, self.redis.subscribe to foo. And then whenever something comes down, it will be implemented, or you'll be seen in self Redis pub/sub listen. As a note, Redis pub/sub.subscribe does wipe out the previous subscription list and subscribe to all those channels, so you do kind of have to keep a list of all the channels to which you're subscribed, and you send it as a list, like so. Events will be sent down to the client, basically immediately, because as soon as Redis does the subscribe, the listen method will pick it up in its generator, and then zip, it goes right down to the client with socket.emit that we saw earlier. Obviously, I can't cover everything here. I'm very quickly running out of time. If you want to know more, I've created a GitHub repository, which I made public about 10 minutes ago. Well, 40 minutes ago. You can look at it here. It's got a lot of code. It has a very working, albeit very, very simple, chat room setup using a Redis backend so that you could see how to do a lot of these things. And I've tried to make sure that it's well commented so that it can be a guide to you if this is something that you need to do for your job or your personal projects or toy projects or whatever. And thanks for attending.
We have time for some questions. If anybody has a question, there's a mic here. Questions? Yeah.
2 questions, one quick, and since I'm the only one up here. Can this be fronted by Nginx, or does this need to talk directly to the web browser?
It can. That's a tricky question. The answer is that yes, it can be fronted by Nginx, but Nginx doesn't have a SocketIO implementation. So probably what you're going to want to do is you'll want to put Nginx in front of it, and then route anything that goes to /SocketIO /anything into your SocketIO server. So you can definitely put Nginx in front of it. In fact, you should do that.
Okay.
On my example repo, I've actually just subclassed the Django dev server, which is a very great development situation. It's a great teaching situation. It's not a great production situation. Fronting it by Nginx is almost certainly the correct approach.
Okay, and how does this work with, like, say, intermittent client connectivity? Like, if your client's mobile, and do messages get redelivered, or do just, if somebody drops off, like, are they just gone?
Sure. So the question is, what happens if a client disconnects for a while? The short answer to that is that I don't know a lot of the details. Right. I think that mostly it gets lost. The notion is that it's a stateful connection. When you disconnect, it does send a message, and there's a way to know that a connection's become stale. Like, say, if the network connection were to come down and you didn't actually send a disconnect, you can know about those. But there really isn't a notion of like retrying. This isn't a task runner. It's kind of like what happens in an online game if you disconnect. Well, probably your character is just going to keep running in the direction that it was running because you never were able to tell it to stop, and then fall off a cliff and die.
Hi. So am I right in my understanding that the number of client connections you can have is limited to the number of open ports on the server instance they're connecting to? Or how do you deal with the limit of connections that you can have?
I don't know a whole lot about the connection limitation situation, to be honest. I haven't used this in a case where I've had enough to run into that problem.
Okay.
So honestly, you have hit the limit of my knowledge. So go, find out, submit a talk for next year, and come back and tell all of us, because we will all want to know the answer to that.
All right, fair enough.
And give us a great talk about how to scale this.
Got it, thanks.
Sure. I'm serious about that, by the way. I'm expecting that 75% of the people here will want to know the answer to that. And I don't have it.
I expect it will scale up to quite a lot. It's not as if you have one thread per thing, per client. And certainly each connection is just an HTTP connection still. So you're not sort of limited to the number of open ports on your server. How close to the WebSocket interface is it? Is it just something completely separate, or is it intended to be like a backfill for WebSocket functionality for clients that don't have that? Or?
I apologize, I did not parse that question.
Okay, so it's essentially a wrapper around WebSockets, a Flash version, and long polling. And
some other things.
And some other things. So how close is it to the WebSocket API itself, or is it just something that's completely separate? It's not intending to just like make the WebSocket API available.
It's not the goal of SocketIO is not to expose the WebSocket API per se. Its goal is to be something that can be compatible. Using WebSocket is great unless you are almost everybody who needs to support their stuff on some browser that doesn't have WebSocket. SocketIO's goal is to give you the basic functionality, sending messages back and forth, and do it in a way such that it will work as well as possible everywhere. So their goal is not so much to implement the entire WebSocket API as it is to make something that has the basic thing that will always work no matter where it's deployed.
Thanks.
Thanks so much.
Of course.
I wanted to throw in a couple of comments, which is that SocketIO will use WebSocket if available and provide this API using WebSocket as the underlying transport. And you're not using a distinct port number for each client connection. you're using a file descriptor. So it's a U limit rather than the port numbers. That's the bottleneck. And on modern Linux, that's effectively
Unlimited, yeah.
Yeah, unlimited. And the reason to use gevent with this is to avoid having to create a thread per client. So definitely wrap this with gevent. You were talking about WSGI, which is totally fine for the Django side. And if you're using Tornado, then there's a great library called SocketIO, which will do the same thing for Tornado.
So I'm going to repeat that just for purposes of anyone who might be watching the video. Basically what he said was I used the example of a WSGI library. If you're using Django or Flask or Pyramid, that's great. If you're using Tornado, which isn't built the same way, that's not its purpose, there's another library called TornadoIO, which will provide the same connectivity into SocketIO, but built around that, that environment structure. I think we have time for one more question.
Last one.
Well, it's more of a comment than a question. Now that you talked about gevent and he mentioned Tornado, a lot of the Twisted fans are probably asking, so what about Twisted? There's an implementation called Autobahn, like the German highway. It's built on Twisted.
Yeah.
It has all the WebSocket implementation. And the best part is that it has a PubSub protocol in it, so it replaces your Redis solution in a much cleaner way. Although yours is very useful, but that one has a built-in PubSub system that works pretty well.
Sure. I'm going to repeat that for the video for the same reason, which is if you're using Twisted, again, my example doesn't necessarily apply to you. The library is called Autobahn, the German highway where you can drive really fast. And it also implements the PubSub piece of it. So all of my Redis piece to use Redis as the PubSub agent isn't necessary.
Yeah. Applause for Luke. And give him. Thank you. Thank you, Luke.